Hi everyone and welcome to the Hangman solution video. How did you get on in coding up the game? Now I'd like to put my hands up and say, I'm sorry. We've been using imports in our code so far, and I threw in a little trick question to see if you could work out how you could bring in words from a different file. Now obviously in order to create this game we could have created a list of words in the same file, but the first task asks you to create a function that obtains a randomly selected word from a separate file called words.py. Now we don't actually cover this concept until section 21, when we cover modules and packages, but I wanted to see if I could get your brain ticking as to how this could be done based on what you've learned so far. If you simply included a list of words in the same file, great, you found a solution for this problem. And if you managed to actually import words from a different file, fantastic. That's exactly what you need to do in the real world. When you come across something you don't quite know or don't know how to do, Google is your best friend. There's a Python community out there that have run into the same problems and issues as you. If you simply Google how to import list from one Python file to another, when we hit return, you can see that we get a Stack Overflow result back telling us how to import a list from another Python file. And if we click on this link, you can see that the person who has posted this has stated that they've just started programming in Python, so I would love a detailed explanation. They're looking to see how they can get a word from file 1 into file 2. Now if we scroll down you can see that we've been provided with some answers, and the answer with the most positive reviews is the one that says, to make things simple, make sure randomwords.py and the selected word.py are in the same folder and directory. They then have a list of words in randomwords.py, and then in the selected word.py file they've put from random words import list of words. And by simply doing a Google search for the problem that you're facing, you'll find that there are people who have already run into the same issue. So if you did go ahead and try to Google a solution for something you didn't quite know, fantastic. That's exactly what we have to do when we develop. We are always on a continuous learning path when working with Python, and I use Google all the time to try to find solutions to problems that I run into. Okay, so with that being said, let's go back to our Jupyter notebook and get coding. Firstly, as always, we're going to deal with our imports. So we know that we want the computer to generate a randomly selected word from a list of words, so we will need to import random. We also want to import our clear output function, which we know is from ipython.display. So we can then put import clear underscore output, and this will just help make our code cleaner at the end when we run our program. And if you manage to get this other import that we need, fantastic. If not, don't worry, and I'll leave it with these two imports for now, but there will be one more import that we'll need to make very shortly. Okay, so with the first task at hand, we're asked to create a function that obtains a randomly selected word from a separate file called words.py. Okay, so my first thought is I need to create a Python file, so I'm going to go across to my Visual Studio Code and start a new file. The language will be Python, and I'm going to save this file as words.py. And the .py just denotes that it's a Python file that we're working with. Inside of words.py, I'm going to create a list of words, and I'm going to call this variable, which is going to store this list, word_list. And I'm going to set that equal to square brackets, and inside the list, I'm going to put 5 random words just to start with. So I'm going to put apple, Python, football, jelly, and the 5th word will be office. Okay, so our Hangman game will be very small to begin with, and we'll be able to guess the word simply after a couple of guesses. But obviously this word_list can contain as many words as we want, and we could download them from the web and simply add them to this file. Now with this words.py file now created, we need to import this file into our code. So this is where our third import will come in handy. In order to import the word_list object, we are going to put in our import section from words, which is the module name. We've labeled it words.py. So from words, we want to import, and then we can put word_list. This will now mean that we can use the word_list object from the words.py file in this Hangman code file. Now, a word of warning, you should save the words.py file in the same location as you've saved the Hangman Jupyter Notebook file. Otherwise, you'll run into issues when importing from words. Okay, great. So let's now run our imports section and just make sure we can actually see our word_list. So if I type word_list and then run the code cell, you can see that we get printed to the screen our word_list, which contains apple, Python, football, jelly, and office. Great. Okay, so in the first task, we're now asked to select a random word from this list, so let's define a function. We'll start by putting the keyword def, and then we'll call this function get_word. And then we can put parentheses followed by a colon. We will then create a variable called word, which will store the randomly selected word, and we'll set this equal to random.choice, and then we'll open parentheses. And if we quickly take a look at the docstring, you can see that the choice method allows us to choose a random element from a non-empty sequence. So the sequence we're going to be putting inside of these parentheses will be word_list. With the random word stored in the variable called word, we then want to return the word, but what we will do to this word is convert this to uppercase. So we're going to use the upper method on this string. So we're going to put .upper and a set of parentheses. So let's check to see if our getWord function works accordingly. If we type get_word and then put parentheses, you can see that when I run this code, we return the word Python. And if I were to run the get_word function again, you can see that we return apple. So we're getting a randomly selected word from the word_list each time we run the get_word function. Okay, so moving on to the second task, we're asked to create a function that deals with all of the game logic. Now, this doesn't give us too much guidance as to what we're supposed to do. So we have to use our own intuition and work through the game step by step, printing to the screen what we would want the user to see every time a block of code is run. So let's first of all define our function that will deal with all of the logic. So we'll first of all put the keyword def, and we'll call this function play. Now, seeing as the goal of the game is to guess the word that's been randomly selected, the function will take in one argument which will represent the word that's been randomly selected. So we're going to include one parameter in our function header, and we'll label this word. We can then put a colon. Okay, so when the play function is called, the first thing that I want to do is to define what the word status is. And when I say word status, I simply mean we need to have a representation of the word that is hidden, i.e. we use dashes to replace the actual letters, to give the user a clue as to how many letters the word has, but doesn't give any of the letters away. So in order to do this, I'm going to create a variable called word_status, and I'm going to set this equal to a single dash or a single hyphen, and I'm going to multiply this by the amount of letters that are in the randomly selected word. So to achieve this, I can multiply by and then call upon the built-in len function, and inside the len function, I can place the word that's passed in to the play function. So at this point, if the word that's passed in is jelly, the word_status would contain a string of 5 dashes. 1 dash for each letter. Okay, so moving on, I also want to create a variable called guessed that simply contains a Boolean value that tells us whether the player of the game has guessed the word or not. So we're going to set this initially to a value of false, because when the user starts playing the game, they haven't guessed the word. Next, I want to have a variable that stores the guessed letters from the player so we can keep track of what they have already guessed. So to do this, I'm going to create a variable called guessed_letters, and I'm initially going to set this to an empty list. But we can then add the letters to the list that they've guessed as the game progresses. Now, seeing as the player can guess words as well as letters, we will also create a variable called guessed_words and set this to an empty list. Okay, so what else do we need to think about? Well, the player can only guess a certain amount of letters before the game is over, otherwise they'll just keep guessing until they win. So we need to set a variable that contains some form of count as to the amount of tries they have left. So we're going to create a variable called tries, and we're going to set this equal to 6, just like the application requirement stated in the instructions. Okay, so this seems like a good start. I think what would be nice next is to ask the player of the game what their name is, so we can give them a personal touch when they start playing the game. So we're going to create a variable called name, and we're going to set this equal to the input function asking, what is your name? After we've asked the user for their name, we're then going to clear all the output from the screen, so we're going to call upon the clear_output function, and then we're going to print to the screen a little welcome message. So we'll print welcome to Hangman, we can put a comma, then we're going to plus the string that's stored in the variable called name, and then we're going to plus an exclamation mark. So at this point we've welcomed them to the game, but if I was playing this on a piece of paper, the first thing I would draw out is a little Hangman diagram, ready to draw the head, the body, the arms and the legs on the wooden frame structure. So how can I go about doing this? Well, we have a little bit of a clue from task 3, where we're asked to create a function that creates an image of the Hangman states. So we could call upon a function at this point and then display the correct image. So let's just think about this. If I were to create a list, and for each item in the list, have it represent a specific image, I could then call upon and access each item in that list, which would be a different state of the Hangman. So let's suppose that we call this function display_hangman. What this function will return is a list, and therefore we need to then pass in what image we would like to be returned, i.e. the image at a specific index that we'd like to be returned. And we're going to have this dependent on the amount of tries that they have remaining. So we're going to pass in tries as the argument to this function. Okay, so to keep this train of thought, let's just tackle the task of displaying the Hangman image. And obviously when we start playing, this will be the first image that we want to see. This does mean that we need to skip to task 3, but that's okay. When you embark on developing a program, you will switch from one function to another, and you'll be looking across multiple files at any one time. And at this point, I think it's a good stage to think about what images we want to display to the screen. So let's jump to task 3 and think of the images that we want to display. So seeing as the play function is printing to the screen a call from a function called display_hangman, we are going to have to create a function called display_hangman. So let's first of all put def, and then we can call the function display_hangman. And we know that the function is being called with one argument called tries. So we're going to create that parameter in the function header, so we can put tries in parentheses. We can then put a colon. So without creating any image yet, what we do know is that we need to return a list at an index value that corresponds to the amount of tries that they have available. So let me explain what I mean. Let's create a list called states. So we can create a variable called states, and we can set this equal to an empty list. What I now need to envisage is that each element of this list is a specific image. So for the time being, I'm just going to create 6 pretend images. So I can put image 6, image 5, all the way to image 1. Okay, great. So we've got some placeholders for our images. Now we need this function to return a specific image. So we know we need to use the return keyword, and I'm going to return an item from the list that's stored in the variable called states. And then I want to index a specific value by putting square brackets, and the value of that index will be based on the amount of tries that the player has remaining. So I can put square brackets, and inside square brackets, we can put the variable tries. Now let's just think about this for a second. If a user has 6 tries, i.e. they've just started the game, and we try to access the 6th element in this list of images, we're actually going to run into an error because we know that indexing starts from 0 and image 1 will therefore be at index 5 and index 6 is out of range. So we actually need to add one more image which will correspond to the initial image that's shared. So let's just add one more image placeholder and we're going to call this initial image. So let's now quickly test our function. If I call upon display underscore hangman and the user has 6 tries, i.e. they've just started, you can see that when I pass in 6 into this function, we return initial image. Great, so the player will be presented with an initial image when they first start the game. Now, if the player starts getting guesses incorrect, we know that we're going to have to decrease the value stored in the variable tries by 1. So let's assume that the player gets a guess wrong and we do indeed decrease the value stored in tries by 1. If we now call display underscore hangman and pass in 5 tries, you can see that when I run the function now, we print image 1, which should theoretically be a progressed hangman, i.e. we add the head at this point so that we show to the user the hangman state. Now let's fast forward and assume that the user loses all of their tries, i.e. their tries equals 0. If I pass in 0 to display underscore hangman and run the code, you can see that we print image 6, and image 6 should therefore be a representation of the final hangman state. So let me quickly create some hangman states that I think will be a good representation. You can create these images however you like, but in the interest of time I will speed up this part so we can focus on the core Python code. Okay, so that should do for the images. Let's quickly check to see what I've created. If I display the final image of the hangman, we get something like, whoops, we do actually need to print the function, so we need to precede this with the print function. When I do this, great, I get a little image of a complete hangman. The starting image will look something like this. Great, so there's no man being hanged at the start. And if I look at midway through, let's suppose that the user has 3 tries remaining, we get an image that looks something like this. Great, so we actually get a little image here that looks like a hangman and has been quite fun to create. Hopefully you managed to create your own images, or maybe you just created a counter of the amount of tries that a user has remaining and simply provided them some verbal update as to where they are with their tries. Either way is fine, you can take the game as far as you like, but this is where my mind went when creating the game. Okay, so with task 3 complete, we can now go back up to our play function, and you can see here that we're calling upon the print display underscore hangman, and then we've passed in tries, and we've just tested this below, so we know that that's going to print accordingly. Now, a key piece of information that the user then needs to see is the amount of letters that are in the word they're trying to guess. And we've already created this in a variable called word underscore status, so we can now print word underscore status to the screen. And just to provide some space, I will also print an empty string. Okay, that's good for now. Let's just test our function up until this point to see if it's working accordingly. So we can run the function's code cell, and for testing purposes, we can pass in random strings as arguments to the word parameter. So if we call upon the play function and we pass in a string with 6 letters, let's say we pass in the word yellow, you can see that we're first of all asked the question, what is your name? So we can put in the user's name. I'm just going to put Sarah for the time being. And when I hit return, you can see that we get the welcome message, welcome to Hangman Sarah. We then get printed to the screen the display underscore hangman function, which we know is a list of images. And in this case, we're printing out the image at the 6th index because they have 6 tries at this point. And then we've got 6 dashes underneath. And this represents each letter in the word that we've passed in this case 6 letters because we've passed in the word yellow. Okay, great. So we're now at the point where we need to start collecting some guesses and working through the conditional statements that captures all of the game logic. So let's just comment out this test, and then we'll go back to our play function and create our while loop, which will be the main logic for the game. Now we know that the game should be active providing 2 conditions are met. Firstly, they haven't guessed the word, because if they've guessed the word, they've obviously won the game, and the amount of tries they have is greater than 0. Because if they had 0 tries left, they've lost the game. So we can put while not guessed, i.e. whilst they haven't guessed the word, which is controlled by the Boolean value that we're storing in the guessed variable, and tries is greater than 0, then we want to create a variable called guess, which is going to store the user's guess, and we're going to then set this equal to an input function asking the player to please guess a letter or a word. And we will then convert this to uppercase because we know that we've done this with the random word that's been sourced from the words module. So with a guess now obtained from the user, we can now go through our conditional statements. So first of all, let's tackle the scenario where they've passed in a single letter as a guess. So we'll first of all put if the len of guess is equal to 1, i.e. they've guessed a single letter, and the guess that they've made is actually a letter and not a number for some reason. So let's just capture that scenario. So we can call upon the isAlpha function upon the guess variable, which we know is storing a string. And if you're unfamiliar with the isAlpha function, all this does is checks whether the string consists of alphabetic characters in that specific string. So it checks to see if the letter is actually a letter and not a number. So if the len of guess is 1 and the guess.isAlpha is true, i.e. it's a letter, then we need to first check to see if the letter that they've guessed is something that they've already guessed. So we then need to have a nested statement that says if the guess is in guessed_letters, well then we can just print something to the screen which says you have already guessed the letter, and then we can put curly braces. We can then say try again, and inside the format method we can pass in the guess that they've made. The second conditional statement that we'll need to then consider is where the guess that they've made is not in the word itself. So we can then put elif guess is not in word, and word being the argument that's been passed into this function, well we can then print curly braces is not in the word. We can then use the format method and then pass in the guess that they've made. We then need to remember that because they've guessed incorrectly, we need to decrease the number stored in the variable tries by 1. So we can put tries minus equals 1. Now because we also need to keep track of the guessed letters, and we've created a variable called guessed_letters, which is a mutable object, it's a list, we can then put guessed_letters dot append, i.e. we're going to use the append method, and we're going to append guess to that list. So we can pass guess into the parentheses. Okay, so at this point they've guessed the letter. We know that we've covered the scenario where they've already guessed the letter because it's in the guessed_letters list. We've captured the scenario where the letter is not in the word. Now we've got the scenario where the letter is in the word and they've made a correct guess. So we'll first of all open up our else statement, and the first thing we're going to do is print to the screen, nicely done. Curly braces is in the word, exclamation mark, and then we will use the format method and pass in the guess that they've made. We then want to append that guessed to the guessed letters so that we capture this guess, so we can put guessed_letters dot append and then pass in that guess. We then move on to a slightly tricky part of the problem. Usually in a game of Hangman, you would then write the letter in place of the dash so that the word slowly reveals itself. So for example, if we had the word yellow and a user guessed the letter E, we would expect the first letter to be represented by a dash. We would then put the letter E, telling the player that they've guessed the letter correctly in that position, and then the remaining letters would also be represented with a dash. So how can we go about doing this in Python? Well, my first thought is, if a user guesses a letter correctly, we need to know the index position of that specific letter. And we also need to be working with a mutable object so that we can change a dash for a letter at any given time. Now, strings are immutable objects, so that doesn't make much sense. So the first thing I'm going to do is create a variable that converts the word _status, i.e. the dashes to begin with, to a list. So I'm going to put word _as_list, and I'm going to set this equal to the built-in list function and then pass in word _status, which converts our string to a list. Now the next thing I want to do is work out the index of the word underscore status where a correctly guessed letter would sit. Now this is slightly tricky, and we have covered a function that will enable us to do this earlier in the course, and the function that I'm thinking of which would be quite useful in this scenario is enumerate. And I'm going to quickly recap what the enumerate function would allow us to do in this situation. So let me just go into a new code cell and create a variable called word which will store the string yellow. I then want to assume that the user has guessed the letter E. So I'm going to also create a variable called guess, and I'm going to set this equal to the letter E. Now after this, if I simply use the built-in enumerate function and pass in word, we get back an enumerate object at this location in memory. But can you think back to what this object is storing? Well, here's a clue. If I wrap this enumerate function in the built-in dict function and then run the code cell, you can see that we're able to associate each letter in the given input into the enumerate function with a numeric index. So at the 0 index location, you can see that that's associated with Y. At 1, we have E. At 2 and 3, we both have the letter L. 4 is O, and 5 is W. So all I would simply like to get out of this is at what index location in the word yellow is the letter guess. So what I'm going to do is create a variable called indices, because there could be more than one index that we're going to return here. For example, if I passed in L, we would expect 2 indices to be returned. So we could put indices, and I'm going to set this equal to some list comprehension, another topic that we've covered earlier in the course. So I'm first of all going to put for I, comma, letter in enumerate and then pass in the variable word. This will loop through the index and the letter in that word. Now, seeing as we only need the index for this specific purpose, I'm going to then precede the word for with the letter I. So I'm going to say I, which stands for index, for I, comma, letter in enumerate word, i.e. for every index and letter in the enumerate word function. But I only want to bring back the index if the letter that we're getting from the loop that we've just created is equal to guess. So after this, I can put if letter is equal to guess. So if I run this code cell and then look what's stored in the variable indices, you can see that we bring back a list which has the value 1 stored in it. And if we take a look at what we've guessed, we guessed the letter E. E is at index 1 in the word yellow. And if I were to change the guess to the letter L and then rerun both code cells, you can see that the indices variable, which stores a list object, now contains index 2 and 3, which do indeed correspond to the index values where the letter L is observed in the word yellow. So I'm going to use this logic in the main play loop to bring back the index for each letter. So let's scroll up and add our logic accordingly. After we've defined word underscore as underscore list, I'm then going to copy and paste what we've just written below so that we get a variable labeled indices, which we know contains the index values for each correctly guessed letter. I now want to update the word as list variable, which we know is a mutable object, it's a list, with the correctly guessed letters. So I can now create a for loop which says for index in indices, i.e. for each value that we see in the indices list, we are going to take the word underscore as underscore list object. We are then going to access the index that we've got from the prior indices list, and we're going to set this equal to the guess that the user has made. Now, because at this point we've got an updated list, we need to now update what's stored in the word underscore status. So we can now put outside of the for loop word underscore status equals, and then we just need to join each element from the word as list. So we can then put equals an empty string because we don't want anything to be included in between the letters. We can then use the dot join method, and we are going to pass in word as list as the object that we want to be joined. So at this point, we'd then have dashes to represent the letters that have not yet been guessed correctly, and we'd have the letters shown where the letter has been guessed correctly. Now, just after this logic, a user may have actually guessed the final letter correctly. So we just want to quickly check to see if a dash is not in word underscore status. Now if a dash is not in word underscore status, we know that we can change the value that's stored in the guessed variable to be the boolean true, which would then mean we break out of the while loop based on our current conditions. Okay, so at this point we've dealt with the correctly guessed and incorrectly guessed letters. What if the user guessed a word? Well, to speed things up, I'm actually going to copy and paste some of the logic we've actually created above, but just change the code so that it deals with word guesses. So we can first of all deal with the second condition where len of guess is equal to the length of the word that they're trying to guess. Because if it is, then they've got a chance of it being correct. And we need to quickly check to see if the guess is all in letters. So we can then have a second condition that calls upon the isAlpha method on the guess that's passed in. We then need to check to see if the guess is in the guessed underscore words list that we created above. If it is, we can then print a message that says, you have already guessed the word, and then curly braces. We can then pass guess into the format method. If the guess is not equal to the word, then we can simply print to the screen, guess plus, and then the string is not the word. We can then take one off their tries count, and then we can append to the guessed underscore words list the guess that they made. Now the final else condition would be the case where they've guessed the word correctly, because we've covered the case where the guess is not the word and where they've already guessed the word. But if these two conditions are not met, then they must have guessed it correctly. So we can update our guessed variable to equal true, and then what we will do is set the word underscore status variable to equal the randomly selected word in its entirety. Now if the guess has a number in it, or it doesn't meet one of the conditions above, we want to have a final catch-all else condition in our outer if statement that just prints to the screen that they haven't provided a valid guess. So we've already tackled the case where they've guessed a single letter. We've also tackled the scenario where their guess is a word and that word contains all alphabetic characters. So we can therefore end with an else statement that prints not a valid guess. Now at this point I'm quite happy with the game logic, but at this point I'm thinking a good idea would be to display the Hangman once again to show an updated version of the Hangman status. So we'll print and then call upon the display underscore Hangman function and pass in the value that's stored in the variable tries. We will also print the word underscore status, and then to provide some space in between each guess, we'll also print an empty string. Now at this point we also need to deal with the situation where they've guessed the word correctly. We definitely want to provide them some form of congratulations message. So after this while loop, we want to put if guessed, which we know contains a boolean value of either true or false. If guessed, i.e. if it's true, then we want to print congratulations, you guessed the word, you win. Else, we then want to print the Hangman state, so we can put display underscore Hangman and then call upon the 0 index, which we know is the final Hangman image. We can then print an empty string, and then we can print, sorry, you ran out of tries. The word was, then we can plus the word, and then we can put better luck next time. And this completes our game logic. So we've now tackled tasks 1, 2, and 3. Let's quickly move on to task 4, where we're asked to create a function that checks to see if a user wants to play the game again. We've had a lot of practice at this, so we can first of all define play underscore again. We can then create a variable called replay, set this equal to an input function saying play again question mark, y or n in brackets, and we can then convert this to a lowercase. We can then put if replay equals a lowercase y, let's just return true. Else we'll return false. Okay, great. The final task we're asked to tackle tells us to produce and call a function that combines the above functions into a single program. So we'll first of all define a function called main, and then we're going to put while true and then a colon, and seeing as we've put while true, we know we need to force a break of this while loop in order to exit the program. But while true, we can then get the word, so we can set a variable called word and set this equal to a call on the get underscore word function that we created in task 1. We can then call upon the play function in which we're going to consume this word that's randomly generated, so we can put play and in parentheses we can put the variable word. We can then check to see if the player wants to play again, so we can put if not play underscore again, i.e. if they don't want to play again, then we can print hope to see you soon, and then we can break out of this main function's while loop. And seeing as we're asked to call upon the function, we can also end this script by simply putting main and then a set of parentheses. And this will initiate the game when a user wants to play it. Okay, so that brings us to the end of the program. Let's just scroll to the top and recap what we've covered. We've first of all imported random, clear output, and a list of words from a separate file called words.py. We've then created a function that randomly selects a word from words.py and returns it in uppercase. We've then created a function that deals with all of the game logic. We have a couple of code cells here that we use for testing purposes, so I'm going to delete these now, seeing as we no longer need them. We then created a function that stores the different Hangman states in image form that we return in list format. We created a function to see if a user wants to play the game again, and then we produced our program at the end in a single function which we then call. Let's play our Hangman game. Now we know we only have 5 words to choose from, so this makes testing our program a little easier. So let's go up to kernel and click restart and run all. When it executes the main function at the very end, we're first of all asked, what is your name? So I'm going to put in Tim for the purposes of this game. Great, welcome to Hangman, Tim. We're then presented with an image and we can see that the word we're trying to guess has 5 letters. So please guess a letter or a word. Let's first of all guess the letter A. Oh, you can see that A is not in the word and the image has been updated and has now got a head for the Hangman. Please guess a letter or a word. The second letter we'll guess is E. Nicely done. E is in the word. And you can see that the image has stayed the same and we're now presented with the letter E as the second letter. Now we know that the randomly generated word is jelly. So let's first of all get a couple wrong and then guess it correctly. So we'll next put the letter O. O is not in the word. You can see that the body has then been drawn. Let's guess the letter Y. Nicely done. Y is in the word and Y has been put at the very end. Let's guess the letter W. W is not in the word. We've been given the right arm. Let's guess the letter B. B is not in the word. We've been given the left arm. Let's guess it wrong again. Let's guess the letter U. U is not in the word and we've been given the right leg. Now we know we only have one more guess here to get this word correct. So I'm going to guess the letters correctly now and we're going to go with letter J. Nicely done, J is in the word. And let's finally guess the word correctly and put the letter L. Nicely done, L is in the word. Jelly, congratulations, you guessed the word, you win. Would you like to play again? Let's quickly play the game again and get all the letters wrong to see if we get the right output. So I'm going to put Y. What is your name? Let's put Ben. Welcome to Hangman, Ben. Please guess a letter or a word. Now just looking at this, our longest word was football. So we'll first of all guess a letter that is correct. Let's put the letter A. Great, so that's working. Now we'll get the letters incorrect. So we'll put P. P is not in the word. Let's guess I. I is not in the word. Let's guess E. E is not in the word. Q. Q is not in the word. Then V. We have one guess left remaining. We haven't done very well in this word. Let's put the letter M. We're then presented with the full Hangman image. Sorry, you ran out of tries. The word was football. Better luck next time. Play again. We can now put the letter N, and we're then presented with the message, hope to see you soon. So we've got a fully functioning Hangman game which randomly selects a word from a separate file. This word list can be as long as you want. It could contain 10,000 words if you wish. But we've been able to use the Python skills that we've picked up over the course so far to work through step by step and create a working game that an individual player can play. I hope you've once again solidified your understanding and you enjoyed this project. We have one more project to go through before we move on to the world of object-oriented programming. If there was any part of this project that you got stuck on and you want some extra clarification, please feel free to get in touch and we'll get your understanding back on track. But for now, well done, and I'll see you in the next video.